All right, so here we go. Example problem number 3. This one's an inclined plane. A little tricky here. First part again is to draw a free body diagram. This one gets a little different. Students sometimes have problems. Here's our 5 kilogram mass resting on a ramp of 37 degrees. It is at rest. Okay, really important. You're told it is at rest. At rest means equilibrium, which means F net equals 0. All the forces everywhere balance. That is way important. All right. Sum of the forces is 0. But let's start by drawing our forces. Free body diagram. Here's our 5 kilogram mass. That's on a bit more of a tilt than it was shown there. So let's go like that. Like that. There's our 5 kilogram mass. The center of that thing's mass is right there. Which way does gravity pull? Gravity doesn't always pulls straight down. The force of gravity is straight down. Mass times acceleration of gravity, 5 kilograms, 9.8 meters per second squared is the acceleration of gravity. This should be pretty redundant at this point. This thing's weight is 49 newtons. Now, again, it's on a ramp at 37 degrees. It's at rest. It's not moving. It wants to probably slide down the ramp, but it's not moving down the ramp. So which way is friction? Friction, by definition, is a force that opposes motion. Friction is going to be a force, in this case, up the ramp. Force of friction. Force of friction is going this way, up the ramp. Now, the ramp, this thing's not falling to the center of the earth. If anything, it would be sliding down the ramp. It's not because it's really sticky. It must be a lot of friction there. But the ramp can't push straight up. The ramp can only push perpendicular to its surface. The normal force, by definition, is perpendicular to the surface. So the normal force, let's see if I can draw, is this way. That's your normal force. But so many students screw up. Sometimes students will do this. They'll put the normal force up there. No way. Wrong. Don't do that. The normal force, by definition, the normal force is perpendicular to the surface. So the ramp, it's going to be perpendicular to the ramp. There's your normal force. All right. Now, if you remember in the notes, we said on a ramp, we're going to rotate our axes. On an inclined plane, we're going to rotate our axes. And here's something super, super cool. These two forces are at right angles to each other. Along the ramp and into and out of the ramp. So the best way to do this is to, instead of having what you're used to as your X and Y, this time we're going to rotate everything to go with our ramp. You're just going to take it and rotate it 37 degrees. So your X-axis is like this, and your Y-axis, oh, that's not, your Y-axis is like that. X, Y. So our force of friction will be here, and our normal force will be along there, And gravity is the only one that's not along our axes. We only have to separate gravity that way. Doing a little bit of trigonometry, not trigonometry, I guess basic geometry with some things here. If this angle is 37 degrees, right? If we were to extend this down to the ground, if that angle is 37 degrees, that's 90. You can figure out what that angle is. That's going to be the complementary. There was another imaginary line going this way. You'd have alternate interior angles. This cut by a bisector, parallel line here, here. This would be 37 degrees. This angle would be its complementary. This angle is 37 degrees. So hold on and clean that picture up a little bit. Whatever angle this is, that angle is. That is going to be 37 degrees. Very, very important. That is key. All right. We know this is 49 newtons, but we have to split that 49 newtons into our pieces. All right. So our free body diagram looks like that. And now we have to figure out what the force of friction is and the normal force and the coefficient of friction. Well, that's basic arithmetic now. Here we go.